Welcome. Let's start with graphing a complex number. Complex numbers are in that format, and the A counts as X and the B counts as Y. So here's our X and here's our Y. So the Y is the coefficient of the I. We then can make this into a point of -4, 2, because the 4 counts as the X, or the -4 counts as the X, and the 2 is the Y. And so we graph that here at -4, 2. We actually write the equation z equals -4 plus 2i. That's the way you graph the complex number. You put the point and you write the equation to match that point. Now let's take a look at what it means to find the absolute value of a complex number. So z is the complex number. It stands for it. It's always in that format. So let's take one. In fact, we'll take the one that we were just looking at, -4 plus 2i. And you essentially use what looks like the Pythagorean theorem, or the distance formula, which of course it actually is. So we put a -4 in for the A and plus a 2 for the B. And therefore that's equal to +16 plus 4 square root of 20, which can never be left that way. You have to find the perfect square that's in it and take out that perfect square. So 2 times the square root of 5, and this would be an exact answer. There would be appropriate times to approximate it in an application type of word problem, but otherwise this is what you are trying to do. Let's get those lines back there. And this will identify this as the correct answer for that. And up here, it was actually putting the point and writing the equation. Now let's take a look further. What we'll do in this next part is to find the polar form. So a rectangular complex number is this, what we just worked with. Rectangular complex number. This is the polar form. Notice that the polar form has the radius and it has the angle. And the polar coordinates are written as a radius and an angle. So we are using that radius and angle. Whereas for a rectangular complex number, we use x's and y's, and so we have an x and a y. But when we're doing the polar form, we have to use the radius and the angle. So what we will do is 3 steps where we will find what the r is using the basic Pythagorean theorem. We will find the angle by using the fact that the tangent of theta is equal to y over x, because we're given what y and x are, or b and a. And then we will put it into this format, and we will have our polar form of the complex number. So let's do that here with z equals -4 plus 2i. So our first step is to find r, or to get r. Get r. We will use the fact that r squared is equal to x squared plus y squared, which means that r squared is equal to -4 squared plus 2 squared, which is equal to 16 plus 4, which is equal to 20. Well, r squared equals 20 means that r equals plus or minus the square root of 20. We cannot use the negative because a distance, like a radius, cannot be a negative number. So what we will do is the square root of 4 times 5 is equal to 2 root 5. So the radius is equal to 2 root 5. Now that we've done that, we're going to get the angle. To get theta. For that, we will use the fact that the tangent of theta is equal to y over x, which in this case means b and a. because we're given A and B. Or we can think of it as X and Y. So that means that the tangent of theta is equal to 2 over -4, which is equal to -1/2. That allows us to use the tangent minus 1 key of -1/2. And that gives us back that the angle in the calculator, that will tell us the angle, and the angle amount is about 26.56, which we can round up. We could leave it 26.6 would be reasonable, but I think rounding it to 27 is reasonable enough here. So we're going to say that theta is approximately 27 degrees. Now that means if we were plotting a particular point, if we were graphing it, we would have 2 root 5 and 27 degrees. Okay. Now, we have to watch something here because it's not actually 27 degrees, and let's identify why. Okay, so it seems like that, but now let's remember something. Let's remember that x is equal to -4, y is equal to 2, which means second quadrant. Oops. And that's because when we look at the quadrants, we see that the x being negative and the y being positive only happens in the second quadrant. In the other quadrants, they're not the negative and positive. Let's make that easier to see for everybody. I'm going to make this a little bit larger. Okay, so it's minus and plus. Here they would be both plus, here would they be both minus, and here it'd be plus for the x and minus for the y. So where we are is this one, the second quadrant. And because we're in the second quadrant, we have to arrange that it's 27 degrees going that way up from the 180. So we do 180 subtract the 27, which gives us 153 degrees. That means that theta equals 153 degrees. So what we're left to do now, and that is the thing. So instead of doing this, I would have 2 root 5 and 153 degrees. Now that we have these two things, the radius and the correct degrees based on the quadrant, now we can write the polar form. Okay, so third, write polar form, which is r cosine theta, okay, plus I sine theta. I sine theta. So we have that as 2 root 5 cosine of 153 degrees plus I sine 153 degrees. Now, we could get the actual cosine and the sine and multiply it all out and get the numbers for those. However, we're supposed to keep it in the polar form, which means using the r and the theta. So we have to keep r here, theta here, and theta here. So that is what we were trying to get to, was the polar form. Now here, we are going to go the opposite direction. We're going to change from the polar form into the rectangular complex number. This is written wrong here, so I'm going to add some words here. Change into rectangular complex number from polar form. That will match what we're trying to do and what we see here. So looking at this example, I have a radius of 10, a degree of 210, and another degree of 210. The good thing is that 210 is on the unit circle. So when you look at the unit circle, you see that the cosine at 210 is negative square root of 3 over 2. And then that's plus I times the sine of 210 is negative 1/2. So now let's first clean up some of this inside part, because that's positive and negative makes that a negative. The 1/2 before the I. And our next step will be to multiply the 10 to both of those. So we'll have 10 times negative root 3 over 2 minus 10 times 1/2 I. So 2 goes into 10 5 times. So we have a negative 5 root 3. And 2 goes into 10 5 times. So we have, oops, I wrote 5 here, what it should be a 3. Minus, so negative root 3 minus 5I. And that is the rectangular form. Oops, let's bring that back. All of that. There, now I got it all. So we went from this polar form into that rectangular form. And all it is just finding the actual cosine sine, then multiplying. If it was an angle that was not on the unit circle, then you would be able to use the calculator and approximate a decimal to a minimum of 2 decimal places. However, this is on the unit circle, the 210 degrees is, so using those is best. Next, we're going to multiply and divide. So here, let's first do some multiplying, where we're going to multiply z1 times z2, and watch what happens. We have the 2 radii, and they are multiplied together, but on the inside, the 43 and the 17 are added together. The 43 and the 17 are added together here. So we have a multiplying, and then we have adding, because the adding is inside with the cosine and the sine. So pay attention to that difference. And then we actually just simply do the 15 times cosine of 60 degrees plus I sine, well, again, 60 degrees. And then we can do like we did above here, because we're trying to change it into, we're going to actually get the amounts numbers here. We'll change it into a rectangular. So 60 degrees, cosine of 60 is 1/2, and the sine of 60 is square root of 3 over 2. And then we multiply 15 times them. So there are 2 ways to do this. 15 over 2 plus 15 root 3 over 2i, or, and so it can be either of these. We can make them decimals, because the decimals for this is a decimal that ends and is exact. 7.5 plus 7.5i. So both of these are acceptable answers, fraction or decimal. These would be considered exact answers. Only because the decimal ends at 0.5 and there's nothing more after it. Now let's do it with a division. And so on the division here, we're going to do the same concept, but notice that in this case, we have 3 and 5, but now they're being divided. So we have division, and then we also have minus here. So these are different from what from the multiplying. Multiplying and adding really goes together. Dividing and subtracting really goes together. So this is an appropriate place to make that 0.6. And then we have cosine 43 minus 17 is 26 degrees. Plus I sine of 26 degrees. Now 26 degrees is not on the unit circle. Therefore, we'll have to do that in the calculator. And we get that the cosine of 26 degrees is approximately 0.9. And then the sine of 26 degrees is approximately 0.44. And then I after it. Now we can multiply 0.6 to both of those. and we get that it's an approximate answer of 0.54 plus 0.26i. And therefore, that is when you divide, you get this rectangular number. So that's part one of this section, and you can go and look at the part two video to continue. Thank you for watching and listening.